welcome to this video. In this video I will be showing you how to build an Android app for custom image classification. So we will be using Teachable Machine for this. This is a product of Google. So let's get started. So this is the basic approach. We'll give a dataset, train it on the Teachable Machine website, export it to TensorFlow Lite, and then deploy it on an Android device. And this is the basic overview, the roadmap for it, what we will be doing. Now let's start with the steps. I have divided 5 steps for this. So let's begin with the first one. Go to the Teachable Machine website. Alright, I've given a note over here that Teachable Machine only has support for mobilenet model as of now. So the only available model on this website is mobilenet. They are working on including others as well, but as of now only mobilenet is supported. So I will be making another tutorial and a few other videos for training this on Google Colab using Keras and TF-Lite model maker. So that will give you an option to train other models as well, like efficient net or inception model. So there are many others like that. So alright, let's just get started. Click on this button. Now there are 3 panes over here. I want you to click on this image project because this is the one that we'll be working on. Now as you can see, there are 2 options over here: standard image model and embedded image model. Now on the one on the right is best for microcontrollers. This will give around 500 KB model, and that will be of 96 into 96 pixel grayscale images. But for the other one, the standard image model, this is 224 into 224 and the size will be around 5 megabytes, and this is better for most scenarios. Alright, so let's just click on this one. I'll be using this one. Now we come to this page. Now this is very simple. Just give the name of the class that you want to train. I'm training 2 classes. One is with mask, one is without mask, and I'm going to simply upload the dataset. You can also use webcam to upload a few images. Since I already have these on my desktop, I'll upload this. Select all, click enter, and it will upload this. Alright, so it's done. Now that is it. Now for without mask, do the same thing. Okay, that's done as well. Now next, train a model, but before click on that, let's have a look what this is. This is the number of epochs, batch size, the learning rate. The default values are good enough to train a decent model. So just click on train model, and this will prepare the training data and start training your model. Just keep in mind you cannot close this tab or change tab when it starts the training process, because that will pause the training process. Okay, it has started the training process, and you can see it says don't switch tabs. So just leave this open. This won't take very long, as these training image classification models is not very complicated. It does not take very long either. This will be done very quickly. And you can also check out what's going on under the hood, what's going on behind the scenes. Just click on this and you will see you can calculate accuracy per class. So you will find what's happening. It had reached 15 epochs. This was the accuracy, and so you can also calculate accuracy per class. let it first finish the training and then we'll calculate everything over here. Okay, once the training is finished, now you can also preview the output over here. You can either select a file, turn the input on and give any image over here. I have a few test images over here. Now let's see what the output for this is. Okay, it is giving without mask on it with 100% accuracy. That's pretty good. Now let's choose another image with mask, and this is showing this for with mask. So okay, the model seems to be working fine. So you can also test it on your webcam like this. So as you can see, this is showing me with mask right now. Now if I remove the mask, it's showing without mask, with mask, without mask, with mask, without mask. So okay, this seems alright. Now I also want to look what happened under the hood. So what the accuracy was at the end. You can calculate accuracy per class, so it will show you what the accuracy was when it finished the training. So the results are very good over here. You can also look at confusion metrics if you want. So alright, this is basically just to give you a sense of what is happening when the training is being done. So alright, next I'll show you how to export the model. Just click on this. Now you can upload your model on this link. Just upload it for the time being so you don't lose the data if you lose your session or get disconnected or anything, or you close this browser. So just upload this and then you can copy this link. You can use this link to run this model that you have just trained. Alright, our model has been uploaded. Now you can also download the TensorFlow model from here. Alright, TensorFlow JavaScript model, and you can use this JavaScript in your code. This will have the uploaded model that I was talking about earlier, the model that we uploaded on this link. Alright, so now what this does is this creates a link and uploads the model temporarily for running inference on it on this URL. So and then it also includes this URL in all these scripts that I mentioned below, the code snippets you'll see at the bottom. So as you can see, this is the URL for our model. Alright, now this is the JavaScript code snippet. Let's look at the p5.js code snippet. This is the one that we have. You can copy it, open the web editor. Alright, this has the default daytime nighttime model preview in it at first. So you will see this output for daytime and nighttime. Okay, if daytime and if I close it, it will be nighttime. So I'm just going to stop this. You can delete this and copy this p5.javascript, this code from over here to this. Now this sometimes gives this token error. In that case, just remove all these scripts and tags. And this should work fine. Okay, so as you can see, this is showing with mask right now. Let me remove the mask. Without mask, with mask, without mask, with mask, without mask, with mask. Okay, so the model seems to be working perfectly. Now let's stop this, close this. This was just to show you how to test the model. Alright, so and then we also have this tab over here to export this in the keras format, TensorFlow. You can use this code snippet to run it on your system or wherever you want. Obviously you have to install a few packages on your system. You can also run this on Google Colab using this code. Alright, it's very simple. This will load the model and then run inference on any image. You can give a test image over here, giving the image path, and then we can also use this saved model format, that is the .pb format, and use that. So there are many ways to do it. Now what we will be requiring right now is this tflight format. So the default is quantized format, so let's download the model from over here. And as you can see, this says over here you can get the Android app example from this GitHub link. I already have given this link on my website. Now we've done the steps up to here. Step 4 we are doing currently, and step 5 where we have downloaded the tflight model and adjust the tflight image classification sample app with your custom model. So you can download this app from here. There are many examples inside this, from image classification to object detection to gesture classification and pose estimation, etc. We'll be using this image classification one right now. Okay, the link is over here, and it also shows what to do over here, the basic steps. So I'll show you what to do in my article as well, so just follow along. I'm still converting the model, wait for it. Okay, it has downloaded the quantized model. Now we'll download the floating point model. Okay, now I have both the model types, the quantized format and the floating point format. So now we can close this. We can also close this website. Now before closing this, I just want to tell you one thing. Now since I had only 2 classes and 700 images per class, even 50 epochs was enough to give a very good model. The output of this model is very good. So if you have a very big data set and a higher number of classes, you can tweak these values and see which gives you best result. But obviously the image classification model trains very quickly, so you won't have to train it for a very large number. So alright, that was it. Now let's close this and start with this 5th step. Now we have downloaded the tflight model, both the versions, the quantized and floating point, and we'll adjust the tflight image classification sample app with our custom model. I'll show you why we need to adjust this. Okay, so I've already downloaded this app. You go inside light examples. Now this is the one that we will be needing. Alright, you can just simply copy this over to the desktop, and now I'll be opening this in Android Studio. You should wait till it finishes this build process. Okay, so we have done this. We have downloaded and unzipped it, and then I've copied it to the desktop. The next step, we have to copy the model.tflight model with metadata and the labels.txt file inside the assets folder. So I'll show you what this means, model.tflight model with metadata. Now there are two implementation solutions in Android Studio for image classification app. One is task library, the other is support library. As you can see over here, this is library underscore support and library underscore task underscore API. So if you are using library underscore support, you won't need metadata to be attached to your TF-Lite model. However, if you are using library underscore task underscore API, you will need to attach metadata with this TF-Lite model that you will be using. Alright, if you have some custom models, that is why we use this library underscore task API. Now for the time being, I'll show you how to run it using libraries underscore support. If you're a beginner, I suggest you start with this because you don't have to create any metadata, and later on, once you get a hang of this entire process, you can later on switch to library underscore task underscore API. You can read more about these two implementation solutions over here on these links that I have given. Okay, now let's move on. So okay, if you have this build process finished, you'll see one thing in the build.gradle for project. The project gradle plugin is right now 4.0.0. Now this can be upgraded, as you can see in this over here. If it gives you this option, it is better to upgrade it to the latest version. I have 7.1.2, so I'll just upgrade it. Okay, that's done. Alright, next. Now as I said, if you're a beginner, I have also mentioned this over here. If you are a beginner, you can just choose this library underscore support option and then get on with it. Now to select this build variant, all you have to do is click on this build, select build variant. This will give you a drop down. Right now this has library task API as default. This is task API debug, so we need to change this to support debug. As for this, you do not need any metadata, and as you can see, the model that we downloaded from the Teachable Machine website does not have metadata attached to it. We have to do that using a separate process that is also inside this image classification Android folder. As you can see, this is where we have the files for the Android project, and this is where we have the other files for iOS project, and then we have this metadata folder where you have this metadata writer for image classifier. You can read everything in detail about this readme document. These are the packages required to run it. So I have made a COLAB notebook for this, and you can also run this on your own system if you have all these packages installed on your system. So I'll be covering this later on. First, let us run it for library support without metadata. Alright, now next we have to make a few changes in the code in Android Studio. First, we edit the Gradle build module file. So in this folder over here, this one is the one we're talking about. As you can see down at the bottom, this has apply from download Gradle, and if you go and download Gradle, what you can see, this downloads the default models for this sample app, the image classification app. This has these models in it right now. If you run this, this will automatically download these models from this link, the TensorFlow hub. Okay, and then we also have the default, it downloads the models into this folder, assets folder inside models, and we already have the labels file for these over here. So alright, so now just you can comment out this line, close this. Next, okay, select build, we can do that later on. Now next, copy your model and labels file to the assets folder. Alright, so let's go ahead and do this. This is the float. model, and this is the quantized format. Alright, now let's use these. As I said, you can delete these. I copied this over here, and next I need to copy the quantized model as well. Alright, so that's it, we have done this step. Now okay, next we have to change the path to these in this classifier float mobilenet.java in the Android Studio. So you can change this for both mobilenet and efficientnet. Now as I said earlier, since I trained it on Teachable Machine, I only have models for mobilenet, so I will be removing the usages for efficientnet. Over here, as you can see, I am running this for library underscore support. Go inside Java, you will see 4 over here: float efficientnet, float mobilenet, quantized efficientnet, and quantized mobilenet. I'll be removing these. Now I'll only be using mobilenet, so first let's change the locations for it. Okay, as you can see, this is the default model that it downloads for the image classification sample app. Again, now since I'm using float, I renamed it to model, and this file remains the same because that is the name of our labels file as well. Okay, so this is done. Quantized mobilenet, I have renamed it to model underscore quant. So that's it, this is also done. Now I've also mentioned this over here. Now if you use all these classifiers, this app won't run, it will give an error since we need models for the other two as well. Alright, for the same object that you have detected. So since we don't have for efficientnet, you can remove the usages. I've mentioned this over here as well. Okay, so now let's remove the usage for efficientnet. You can delete this, or better safe delete, so it will show you the usages. I'll see the usages. Okay, as you can see, we have the usage inside the classifier file. This file, this is the one. So you can remove this, and also I want you to change this maximum results to 2. I'll show you that in the next step. First let's remove these two models. Okay, that's done. Now next, as I said, I also made a few other changes in the code since I am using only 2 classes. So the default number of classes displayed in the sample image classification app is 3. So if you run, before making any changes to this, if you just download the default image classification sample app, you will see when it gives you the output, it has 3 classes that are detected at a time with the probability of each class mentioned after it. So there will be 3 rows. So as you will see in this photo, I have 2 over here. It normally has 3 for the default sample app. Okay, so to change this, I have made a few changes in the code. The first one being this, change this to 2, and now we can also safely delete this efficientnet. Okay, this is done, and after this you have to make one change in this app Java, go inside this. Okay, this has quantized efficient net. I'm going to change this to quantized mobile net. One more change that we have to make over here is in the recognitions row over here. Yes, as you can see in this function, show results in bottom sheet, as I told you, it shows 3 rows for the default the sample app that we have that comes from the TensorFlow website. So since I have only 2 classes, I am removing this. You can also comment out this code or just delete it. Okay, that's it. We only have 2 rows now. Alright, okay, so this is done. Now one more change that we have left is inside this, in app res folder values we have strings.xml. Remove these first two as we are not using these, and that is it. Can sync now. Okay, so the sync has finished. Now I want to run an emulator. I'll first run this on an Android virtual device. Alright, before I run this, there is one more last change that I forgot about. This one, since as you can see, since we've already deleted this efficient net, you can also remove this. Now everything should work just fine. I'll first sync. Okay, that was successful. Now we can build it. I already have this AVD running. Okay, so as you can see, the model is running. You can also see the inference is being done, as it is showing the inference time is changing. Alright, this is for quantized mobile net, that is the default one. You can change it to float mobile net and then use GPU as well. Okay, let me change this to another location, see if the class changes. Right now this is on a virtual device, so obviously you won't see the results, the appropriate results. It is basically just throwing garbage for the 2 classes that we have trained, so that's nothing to be worried about. Now alright, now let's test this on our device. But before running on my device, now next what I will do, since we are done with this entire process, what I am going to do before this step, running it on my device, I'll change the implementation now, as I talked about earlier. This is default, but I changed this to library underscore support. As I said, for beginners this is much easier, much simpler to use, but in future I want you to use this because this is much recommended for running our custom models. Okay, so now I'll be changing this to, I'm closing this and I'll be changing the build variant to task API debug, and that is it. Now we are using this implementation, so we'll be making the changes over here. Now just as we did for that library underscore support, we'll be doing this over here as well. Rename this to model.tflight. Now as you can see, there is no mention of the labels file over here, so you cannot give the location to the path of that labels file over here in this task API implementation. So that is why we have to attach the labels file with this model.tflight. That is what we do when we create the metadata. We also add a bunch of other necessary details like the description of the model, etc., into the metadata. So alright, let's do this for the quantized version of this model as well. I named it model underscore quant, and that is it. Now I want to delete this efficient net as I don't have these. You can view the usage. We have it in the classifier file. First let's remove this so it becomes easier to delete. I'll also make this change over here, change the maximum results to 2. Okay, so that was enough. Now we won't get any errors or warnings while deleting this efficient net classifier for both the types. Okay, so that's done. Now if you run this, even though it will run the model, but it won't show you any output, that is, it won't show any class names because we have not attached the labels or given the path to it. So as you can see, this is just giving the default like this. We don't want it like this. We want to attach the names to the TF-Lite model, and for that I have given this COLAB notebook on how to create metadata for this. You can also do this on your system if you have all the necessary packages installed. If you have Anaconda, you can just install a few of these packages mentioned in this metadata folder inside image classification for the Android app that we are using. We'll see we need these. Alright, and then you can just run this script. You have to make a few changes over here according to your model. Now I'll show you what changes you need to make. First, since I'm doing this for my TF-Lite model, I'll be uploading this to a folder here. First, create a folder named metadata. Okay, now we will mount our drive and navigate to the metadata folder. Click on this, allow. Now next, there are only 5 steps, so this is not very long, very simple. Next, upload the following 3 files: the script file and your model that you want to attach the metadata to, and the labels file, okay, with the names of the classes written in it. So alright, okay, so we have these 4 files over here. Now first let's change the labels file. Okay, we can leave it as it is, that's alright. Now this script file, we need to make changes. Change this to the name of your model, model.tflite. You can give the name that you want, the image width and height. Now the rest you can leave it as it is. Next change you have to make is number of classes. I have 2. Author also, you can change this to whatever you want. And the next, the model description. This is the standard description for the image classifier app. Identify the most prominent object in the image from a set of categories. This is %d, that is number of your classes. Okay, so this will be 2. Alright, and again, now you have to change this for different models. Right now our model is from Teachable Machine, so this gives us the 224 into 224 pixel image width and height. Alright, so that is for mobilenet. That's it. There's not much change that you need to do. Next step, just install this tflight support, and then finally we will run this command, the Python script, part to your model file, part to your label file, and then finally the export directory. Okay, I don't want you to confuse this model with the one that we have already uploaded. So what I will do is create another folder inside metadata and call it model with metadata. You can create a new folder here. Okay, we'll be creating the model over here. Okay, we have this folder over here. Now you can run this command. Okay, so as you can see, the metadata JSON file has been saved to this folder, and the associate file that has been packed to the model is labels.txt. So this has been packed with this model file. We have this new model over here. Alright, you can download this. This is the float model. Now we have to do the same again for the quantized format. Okay, so as you can see, this is v1. I'm using v2. You can also change that. So obviously this is just for demo that I'm showing you, so these are not necessary right now, but when you make an official model you have to make all these changes, so it is easy for you to understand in the future if the need arises what the model is, its description and everything. So alright, because you cannot do this again every time whenever you're running the model inside your Android app. It gets very cumbersome if you have multiple models for different versions of it, like for efficient net and the two different versions, float and quantized for it, then mobile net, two versions for it, and so on. So it gets very complicated. So just do it when you're creating the model and save it alongside it. That's a better option. Okay, so the next model that we are doing is for model underscore quantized. This was the name. And okay, there are no other changes. Control S. And now okay, so now as you can see, I have given the path to the quantized model. Now this is done. Now you will see this quantized tflight format over here. This is the name that we gave inside this metadata Python script. This name. Alright, now make sure to set different names for it, because you'll be using these in the same assets folder as we did for the library support implementation. So alright, now we have these two models and I'll be downloading these models. You can also download these JSON files. Okay, I just need these models for now, and I'm going to copy it inside the assets folder. So I will be deleting this, and now if I run this, you will see that we'll see the names of the classes as well. Okay, so as you can see, now we can see the names even though we are running library task API. That is our default, the selected one right now. As you can see, task API is the selected active build variant. Okay, and we are seeing the names of the classes. Okay, so now let's shift this around to probably see some change in the output. Okay, so the output is changing now. As I said, for the other implementation, this is just on a virtual device. So obviously the output is garbage for both these two classes, so that's nothing to worry about. You can change these models from here. Now this is only temporary, because in my next video, my next tutorial, I'll be training this using a COLAB notebook using TensorFlow and Keras. So for using that, we'll be able to train all the models, EfficientNet or Inception or mobilenet. So you won't have to make these adjustments in this Android app. But even then, the only adjustment we need to make is for setting our app for two objects that we did earlier on, wherein I changed this value inside this camera activity to 2. I set this to 2, and then I commented out this is the third row. Alright, as you can see from the function itself, show results in bottom sheet. Since we only have two objects, the maximum that we can have is obviously 2. And obviously I also set a value for this in both these library support and library task API, this over here. Alright, for classify.java for this library support, and as well as this. So that is the only change that we need to make the next time around. It's not very complicated, it's very simple. I just adjusted it for two classes and then removed the usages for the EfficientNet models that were not being used. I did not have those models, so I just removed all the usages in the code for that, for whichever implementation I had. So I'll be sharing this entire repository on my blog at the bottom, so you don't have to worry about it. You can just download it from here. Alright, okay, so the final step, now that I've shown you everything, the last thing that we have to do is connect this to an Android device and then show you the output. Okay, run this. Alright, so as you can see, now I'll be giving it a few images. This is without mask. Okay, so as you can see, now I'm testing this on images. Alright, so but okay, I just want to do one more thing. I'll stop this. Okay, now to change the camera, what you can do is go over here inside app Java, this examples classification app, and then inside this legacy camera connection fragment. Now down at the bottom we have this camera facing back. You can change this to camera facing front. Okay, and then when you run this on your mobile, you will see that now it will show the detection on the front camera, so you can see your own face. Alright, let's run this. Yes, terminate the app on our mobile and then install it again. Mask, without mask, with mask, without mask. So okay, this is perfect. Let's end this. Alright, coming back to this, so okay, we've tested this on our Android device as well. So if you have three classes, you don't have to make this change. As I mentioned this over here, I have two classes, so that is why I'm changing the code a little bit. If you have three or more, you don't have to make those changes that I did. And I've also given a few important links over here. Make sure to go through these. Now I told you about metadata, so as I've given these links, you'll understand more about what goes on behind this, what is written inside metadata. Okay, the model information, the input information, the output information, and as you can see, we add this normalization also inside the metadata. So for float model, this is how it should be. For quant model, and these are the things that you might want to read to get a better understanding of this. Okay, then as you can see, we have this command that we use to create it. Finally, you can, the second tab is basically the same. In the same tab over here you can change this from here and read more about this for image classifiers, for object detectors, and other models like natural language classifiers and audio classifiers. Alright, so okay, that was it for this tutorial on how to build an app for custom image classification, for your custom object image classification. Okay, if you've enjoyed this video, please click on the like button and make sure to subscribe to this channel. And alright, I'll see you in the next one.